All right, so I'm going to work out the problems from today's bell ringer because they were a great variety of problems that help us progress in our work as we're learning the new material. Okay, so this first problem, the direction said solve using substitution. Now, normally when we solve using substitution, we look for the variable in the problem that has a coefficient of 1. Now, here's the issue with this problem. There is not a single variable that has a coefficient of 1, so that means I'm going to have to choose a different one. When I tackled this problem, I chose this second equation and I solved it for x. Now, I think I did that because of the 2 and it being a positive 2 sitting there for x. So I knew it looks like it would be an easier process. So when I did, I added 7y to both sides. And then I had 2x is equal to 7y minus 17. And of course, my next step, I'm going to divide everything by 2. And yes, this means I get fractions. So I get 7 over 2y minus 17 over 2. You could also rewrite this as decimals, since they are terminating decimals, as 3.5y minus 8.5. Those are both fine options. Either this option or this option works. In fact, actually, when I'm going to go through the problem, I'm going to start working with the fractions and then I'm going to change it over to decimals. But it has a pretty process and pretty answer here, okay? All right, so now I'm going to continue the problem. So I solved for, and I got my x was equal to 7/2 y minus 17 over 2, or x was equal to 3.5 y minus 8.5. I'm going to plug it into the other equation. So when I do that, I'm going to get negative 5 times 7/2 y minus 17 over 2. Minus 8y is equal to 17. So again, my next step is to distribute. Now again, I'm going to play in fractions just so you can see it. So when I distribute here, I get negative 35 over 2y plus 85 over 2 minus my 8y is equal to 17. Just like before, I'm going to combine like terms. Now, here is when I switched to decimals for whatever reason. So when I did, I ended up with negative 25.5y plus that 85 over 2 is equal to 17. Again, just like before, even though these are fractions, we're going to subtract 85 over 2. 85 over 2. And here's where it's actually awesome. You end up with negative 25.5y is equal to negative 25.5. So here, anytime you have the same number is equal to the same number, but you have a variable, you know that the answer is 1. So y equals 1. So now that I know that y numerically equals 1, I can plug it back in anywhere, but I'm going to plug it back into this portion of the problem. So when I do that, I get x is equal to 7/2 times 1 minus 17 over 2. And x, thus, when 7/2 minus 17 over 2 is simply negative 5. So my final answer should be negative 5 comma 1. That is my final answer to this problem. Yes, it took more steps. Yes, there was an ugly journey, but the final answer was super duper pretty. So it is worth it. And sometimes you're going to have to tackle problems like these. They are few and far between, but you will have times where you have to be able to handle a problem of this level of difficulty. All right, the second problem on our bell ringer, we had two equations. Negative 2x minus y is equal to negative 9, and 5x minus 2y is equal to 18. So I am looking for which coefficient there, which variable has a coefficient of 1, or a negative 1 in that sense. Well, as you can see, this one right here has that coefficient of 1 or negative 1. So I'm going to solve this top equation for y. That's what I'm going to do. I'm going to solve this top equation for y. So when I do that, I'll go ahead and rewrite the problem over here. I have negative 2x minus y is equal to negative 9. So again, you guys have been great at this. So if I'm solving for y, my first step is I'm going to add 2x to both sides. And then I end up with a negative y is equal to 2x minus 9. Well, again, I am not happy with that negative y. So as you guys have told me time and time again, I'm going to divide everything by negative 1 or change the sign of everything. And when I do so, I end up with y equals negative 2x plus 9. So I now have my variable solved for. So now I can plug it into the second equation because I brought it from the first equation. So I'm going to plug it into the second. When I do so, I get 5x minus 2 parentheses, negative 2x plus 9 is equal to 18. Again, next step, you guys have been great at. We're going to distribute. So you get 5x plus 4x minus 18 is equal to 18. Combine like terms for your next step. 9x minus 18 is equal to 18. You want to isolate the variable now, so we want to add 18 to both sides, which leaves us with 9x is equal to 36. Continue to isolate the variable, and I'm going to divide both sides by 9, and x is equal to 4. So once I have done that, now I can numerically plug that x equals 4 value back into this equation right here to determine the numeric value for my y. So when I do that, I get y equals negative 2 times 4 plus 9, which equals negative 8 plus 9. So y is equal to 1. So my final answer that I would write, my solution would be 4, 1 for my ordered pair. All right, so now I asked you to graph. And here I started you off with graphing systems of equations. So your first equation was y equals 1/3 x minus 3. And your second equation was y equals negative x plus 1. So of course the first thing I need to do is I need to draw my coordinate plane. So 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. Okay? So my first one I'm going to graph in red. So again, as I've talked about, this is mx plus b form, which means b is my y-intercept. So I'm going to plot my y-intercept at negative 3. And then I'm going to move my slope up 1 to the right 3, up 1 to the right 3. I didn't do a good job of this. And I'm going to graph my line. Okay? Now, I'm going to go over here to the blue line. So it's also an mx plus b form. I don't have to do any algebra. So I'm going to start at positive 1. I'm going to go down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. So even though my lines are drawn horribly at this point, I find the point where they cross, which is 3, negative 2. That's this point right here. And that would be the solution to this graphing systems of equations. All right, for this next graph, I gave you y equals negative 2x plus 2. And I also gave you y equals negative 2x minus 2. Now, I'm going to go ahead and start my graph, but one thing that you might notice right away while looking at these equations is their slope. You might look at their slope. Because if you look at their slope in the algebraic sense, right away you see this one has a slope of negative 2. This one has a slope of negative 2. Well, there's one condition where two lines have the same slope, and that's parallel lines. Well, parallel lines never cross. So I should be expecting these lines to never cross, which means my answer would be no solution. But let's make sure, because it did ask me to graph them. So my red line, I'm going to start at 2. I'm going to go down 2 to the right 1, down 2 to the right 1. So there we go, graphing my line as well as I can. And then my blue line, I'm going to start at negative 2, but my slope is still negative 2. So I'm going to go down 2 to the right 1, down 2 to the right 1, and I draw that line. So sure enough, they do not cross. So my final answer would be, indeed, no solution, because they are parallel lines, so they're never going to cross, so they're not going to have a solution. All right, so then I asked you to graph, and I threw you into inequalities. So the first one I asked you to graph was x is less than negative 5. So when I draw my graph, the first thing I have to do is I need to pretend this is x is equal to negative 5 when I'm thinking of graphing. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, and 4, and 5, okay? So where is x equal to -5? Right here. When I'm thinking of a line, I'm going to draw a vertical line because x equals -5 here, x equals -5 here, x equals -5 there, etc. Now, looking back up here, remembering our knowledge, since there is no bar under this inequality, I am going to keep a dotted line. So I have my dotted line. Do the best you can. You can do dashes if that's easier for you. There is my line. But I'm not done with this problem because I need to determine where is x less than -5. Well, is x getting smaller numbers over here, or is it getting smaller numbers over here? So, of course, if you need to label. This would be 1, 2, 3, 4, 5. This is -1, -2, -3, -4. Over here, you got -5, -6. Keep going. So which side is x getting smaller than -5, or which side would x actually be less than -5? This side. So you would shade on that side, and you would be done. That's the end of this problem. All right, the last problem on today's bell ringer was y is less than or equal to 4/3 x minus 4. So this particular problem is more like our other guys. So we're going to graph. The joy is right here. Love it when this happens because then I don't have to pay attention to the dotted line. I get to draw a solid line, so I'm happy about that. So I still need to label 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. No reason for the 7s, just picking random points. So I'm going to plot this. Well, again, this is still mx plus b. So I'm going to go down 4 and plot a point at -4. Then I'm going to move my slope, which is up 4 to the right 3. I get to draw a solid line. Now, two different ways that you can figure out where to shade here. So as I talked in the other video, and as I've talked in class, I talked about how Ms. Maxter talked to me last year and said, okay, we're going to look at the y-axis. And we're going to go up here and we're going to read this statement. And this statement says y is less than this line. So if my line is here, I want to know, is y getting smaller up here or is y getting smaller down here? That's going to help me determine where I shade. Okay, well, I know if I'm going up in this direction, y is constantly getting bigger. If I start here or even start there and go down, y is getting smaller. So I am going to shade on this side. Now, another way of figuring this out, because I had students say, that is not sticking in my brain. So I said, okay, how I used to teach it was, I would always tell students, choose a test point. Okay? Choose a test point. Now, I'm going to choose this point right here. I'm going to choose my test point of 0, 0, because it's the easiest mathematically one to do. 0, 0 is on this side of the line. Okay? It's on this side of the line. I'm going to plug in 0, 0, 0 for x, so x equals 0, y equals 0 into the equation. When I do so, I get 0 is less than or equal to 4/3 times 0 minus 4. So, simplifying that down, I get 0 is less than or equal to, well, what's 4/3 times 0? What's anything times 0? It's 0. Okay? So I get 0 is less than or equal to -4. So I ask myself, is this a true or false statement? Is 0 less than or equal to -4? No. So since this is false, I'm going to shade on the opposite side of this point. Since the point I chose here created a false sentence, I'm going to shade on this side of the line. Just another way of doing it. Pick one that works best for you and go with it.